So, we welcome you all again back to the practical hands-on on implementation of blockchain application using Python on IoT data. So, in the previous part we have discussed about how to communicate data from Google Colab to Ubuntu, right. So, we have used MQTT protocol in the previous part. So, by using MQTT protocol we are sharing the data from Google Colab to the blockchain network there. So, in this part I will be showing you how to receive data on Ubuntu machine. So, you can quickly open your Ubuntu on Windows, or you can open the virtual machine or the virtual box, it is up to you. So, I am having Ubuntu on Windows. So, I am using a laptop which is of Windows 10 operating system. So, yesterday I have installed Ubuntu on Windows in order to demonstrate the task, which is building the local blockchain by using Python. So, here I am creating a blockchain network where by writing a Python program from scratch. So, you can use this as a lab assignment also, because in some colleges people are having labs in blockchain. So, you can use this as a lab assessment also. So, with I have shared the Google Colab notes in the WhatsApp group. So, I hope you have received it, and you can also quickly open that if you want to start writing the program. So, I will type the same program on the Google Colab for your reference, but I will do it on Ubuntu, but in the parallel I will copy paste it in the Google Colab for reference. So, here we have created a function in the Google Colab where we have taken some random values from the sensors and then we started publishing the data. So, let us go back to the Windows operating system or the respective desktop PC. So, that desktop PC will be acting as a local machine. So, on the local machine we are now implementing blockchain network there. So, let us jump back to the practical hands on. So, the main agenda of this session of part 2 is to show you how to receive data from Google Colab to the blockchain network, and then we will create a simple blockchain network by using the process of blockchain and by using Python libraries and all. So, we will create a local blockchain. So, by end of this session you will come across how to create a local blockchain, and you will come across how to connect IoT data with blockchain, and also you can able to see how blocks are connected to the chain, how the hashing process will happen, and how to create a proof of work. Okay. So, you will be understanding lot of things around it. So, from the last few days we are studying all these techniques, right, how to create a proof of work, how to have a consensus, how to have a genesis block and all. So, today I will be showing all the technical terms in practical hands on with Python programming language. So, do not focus on the length of the program, just focus on the what type of techniques we are using and what kind of syntaxes we are using. So, just focus on the methodology, okay. Do not focus on the length of the program, but if you focus on the length of the program it will be very complicated for you, but if you start loving the program it will be very simple for you, okay. So, let us jump back to the hands on. I hope you are loving it. So, in the previous part, so let me brief it. So, in the previous part we have created a function which is published to blockchain, and we have infinite loop here. We have a time stamping frequency of 5 seconds. So, for every 5 seconds it keeps publishing the data. So, I am audible to everyone, right. So, I just got it out, okay. If I am audible, please say yes, so that I can continue from there. Okay. So, let me open, so let me magnify the screen, okay. So, I am having Ubuntu on Windows, you can also open that, click on Windows button. So, when you have Ubuntu on Windows, so you will be getting this Ubuntu icon, right. So, which to the recently added, if you install it yesterday, so to the recently added you will be able to see Ubuntu here. So, let me click on Ubuntu. So, if you click on Ubuntu, then immediately Ubuntu for Windows will open. so in a couple of minutes. So I hope you are having this right, because I am able to create a blockchain network on Ubuntu. So you can, if your operating system is Ubuntu directly, then no need to install all this, you can do it directly. Or if your operating system is Windows, you can install this plugin. But if you want to install this plugin, yesterday we had a lot of discussion in the WhatsApp group, right? So many of you are suggesting how to enable this Ubuntu for Windows. So let me quickly show you that. So there will be a developer settings in the, there will be developer settings here on the Windows. So developer settings, okay, you will be having developer settings. So you need to click on the developer settings. So when you click on the developer settings, you have to enable yourself as a developer, okay. So let me show you how to do that quickly. So you will have this developer mode, okay. So you have to enable the developer mode. So in the developer settings, your developer mode has to be enabled, and this is the first step. You have to enable the developer mode, and the second step is that, so after that you have to open the control panel. So after that you have to open the control panel. You have to open the control panel app. And you have to click on programs. So here you will have turn Windows features on or off. So here you will have this option, which is to enable the subsystem. So here you will have an option, little option will be there, Windows subsystem for Linux. So you have to enable this by clicking on this checkbox. You have to enable this Windows subsystem for Linux. So you have to follow these two steps. What is the first step? You have to enable the developer settings, okay, you have to enable as a developer mode. And then second step is you have to enable the Windows subsystem for Linux. So after doing these two steps, you have to install Ubuntu for Windows. I have given the link yesterday, or you can go to Windows Store. So you have to enable this, and then you have to click on OK. So as of now you can able to see tick mark here, right, which means it is enabled. So and then third step is you have to go to the Windows Store or the Microsoft Store. So in the Microsoft Store you can search for Ubuntu, so you will get the options there. So this is Microsoft Store. You can click on search. In search you can search for Ubuntu, okay. So when you search for Ubuntu, you will be getting Ubuntu app, okay. So I have installed this. You can also install Ubuntu 20.04 or Ubuntu 18.04. It is free, right. So you have to click on this Ubuntu. I have given the link for this Ubuntu app, okay, which is a plugin where you can there was some problem. Okay, so here you will get. So when you click on this, if the Ubuntu is installed, you will have launch. So when you click on launch, immediately you will be able to see this window. So when you click on launch for the first time, it will ask you to enter the username and password. You have to enter the username and password. And when you enter the username and password, from the next time it won't ask any username and password. With the same username, it will be you can able to see here. You can able to see some username like, I have given my username as madhu Pvt. Okay, so that is why it is able to see. You can able to see here madhu Pvt at the rate of some desktop name, which is the name of the desktop. And then you can able to see negation $. Okay, so when you install, when you do this 3 steps. One is enabling the developer mode, and the second step is you have to enable the subsystem for Windows subsystem for Linux, and then you have to install the Ubuntu app from the Microsoft Store. So when you do these 3 steps, immediately it will you can launch the Ubuntu on Windows, and then it will ask you to enter the username and password for the first time, and then you can able to see this. Okay, so hope everyone have opened it. Hope everyone have opened it. Let us start the programming part. So here we have installed some packages yesterday, right? I asked you to do that for Hyperledger Fabric. Tomorrow I will talk about Hyperledger Fabric. Today I will be talking about how to create a blockchain, local blockchain in Python. So that will help you out in in sharing your knowledge with students also. So let us quickly install some package, let us check what are the packages available here. Okay, let us check what is the Python version available in particular. Okay, so let's look into it. Okay, let's type Python, enter. You can able to see my Ubuntu on Windows shell, right? So I have increased the font size also so that it will display properly. So Python, enter. So when I type Python, enter, it is showing Python 2.7 version here. You can able to see 3 greater than symbols, which is nothing but Python shell. So here if you say 2 plus 3, it will give you the answer, which is like Python shell, which is Python 2.7. okay. So I wanted to use Python 3. okay. So Python 2 I will be using for tomorrow session, Python 2 for Hyperledger Fabric. I will use Python 3 for creating the local blockchain for IoT data. So let me exit from this. Let me type Python 3 as well. Okay, Python 3 is nothing but Python 3 interpreter. So there are 2 different versions in Python, Python 2 and Python 3. So generally there was no support from January 2020 on Python 2 officially. So we have Python 3. So when you type Python 3, then you can able to see Python 3 shell there, which is installed on my Ubuntu system. So Python 3.8.2 is available on my Ubuntu system. So you can also able to see your Python 3 version, which is installed on your machine. So which is like again there are 3 greater than symbols, which is nothing but command the Python shell. So when you type 2 plus 3, immediately you will get the answer. So which is like Python shell is interactive. So let me click on let me type exit, bracket open close. So when you type bracket open close exit, then immediately it will come out of Python shell. Okay, so there is Python 2, Python 3, so that is installed. Okay. So have you checked? So can I go for next step? Okay, if you are not done, please stop and check, and you can play the YouTube video live, right? So let me show you how to install the package. Let me show you how to install the package. So here, before doing that, we have to install, you have to type pip, pip. So when you type pip, you should not get pip is not recognized. Okay. So say pip 3, I guess. So pip is nothing but on Google Colab we have installed it, right? So on Google Colab we have installed a library called pav-mqdt. So at pav-mqdt we have installed by using pip command, right? So here on my Ubuntu machine there is no pip, but there is pip 3. So the versions are different, but does the same action, pip 3. So for you also you should get this, it says that pip 3 usage is this, commands are this. Okay, if you get pip 3 is not found, then we have to install pip 3. Okay, have you got something like this, or have you got pip 3 is not recognized? Okay, please let me know in the YouTube chat. If you get pip 3 is not a recognized command, then you have to install some package. Okay, so let me show you how to install that package. So let me clear the screen. Okay. Yep. So let me show you how to install a package. How to install this pip 3 package is sudo apt install python 3 -pip sudo apt install python 3 -pip sudo apt install. You can see my browser, you can see my screen. I have written a command called sudo apt install python 3 -pip. So when you hit enter, immediately it will connect with, so it will ask, it is asking the password. Okay, so let me enter my password. Okay, so it will try to connect with pip and try to install the python 3 -pip package on your Ubuntu machine. Okay, so what is the command? Sudo apt install python 3 -pip. Sudo apt install python 3 -pip, that is the command to install. So when you hit enter, generally it will ask password because we have a password for your machine, right? So we have to enter the password, and then when you hit enter, so pip 3 will be now installed on your machine. So this is how you need to install the packages. Okay, sudo apt install package name. So here python 3 -pip is nothing but pip 3 will be installed on your machine. Pip 3 will be installed on your machine. So pip 3 is generally connected with python 3. Okay, so we have python 3 on Ubuntu machine. Now pip 3 is connected with python 3, so that we can install packages for python 3 by using pip 3 here. So we have to install pip 3 first. Okay, so I guess yesterday after installing the Ubuntu for Windows, I have installed this package. That is why for me it is showing, but for you I guess you will get command not found. So immediately you have to install the package by using sudo apt install. Okay, so after this step, we have to install the library called paho-mqdt, right? Sudo pip 3 install paho-mqdt. Sudo pip 3 install paho-mqdt. Okay, let me clear the screen for you so that it will not mess. So sudo pip 3 install paho-mqdt. Okay, so when you install this library, then we can use mqdt communication on our Ubuntu machine also. Sudo pip 3 install paho-mqdt. So this is a library, right? So paho-mqdt now will be downloaded through pip, and it will be connected with, so for me it is already satisfied. For you the library will be downloaded and it will be installed with python 3, so that we can use python 3 for programming on Ubuntu here. On Google Colab also you will have python 3 only. Okay, so on Google Colab you will have python 3. Here also you will have both python 2 and python 3 on Ubuntu, but we are using python 3. Okay, as pip 3 is connected with python 3. Pip is no longer available. Okay, so we have to use pip 3. So on Google Colab pip is nothing but on the back end of the Google Colab pip will be connected with pip 3 there. So here, as we have python 2 and python 3, we have to use pip 3 in particular in order to install packages for python 3. So if you see, requirement is already satisfied on my Ubuntu machine, saying that the package is added to python 3.8. So here it is not showing python 2, right? It is showing python 3.8, which means that the package is added to python 3. Okay, so we have installed pip 3 and we have installed package. Now we can create a folder. So let us create a folder. You know how to create a folder, right? mkdir space say, so I'll type bit -mesra, whatever, mkdir space bit -mesra. So make directory, right? You know the syntax, make directory, which is nothing but creating a directory, and then cd space change directory bit -mesra, cd space bit -mesra. So change directory, so it will enter into bit -mesra there. So thereby in blue color you can able to see here bit -mesra. So your shell is now in bit -mesra folder. Bit -mesra. Now here I will create a file, or here I will create a Python file for blockchain and also for MQTT. Okay, let me create a file. Let me create a Python script in particular. to receive the data from the Google Colab first, and then I will connect with blockchain. So, here let me type the program, let me create a script sudo space nano space, okay. So, MQTT sub dot py, sudo space nano space MQTT sub dot py. Sudo space nano space MQTT sub dot py, enter. So, when you hit enter, sudo is nothing but taking administrative permission, because here Madhu IoT is not root user, it is not super user, we have to take permission from root user. So, sudo is nothing but taking permission from root user, nano is nothing but name of the editor, and MQTT sub is nothing but name of the file, and extension is .py. So, we are creating a Python script. Nano is the editor, Python 3 is the interpreter. Nano is the editor, Python 3 is the interpreter. So, when you hit enter, so you can able to see an empty file which is complete black file, okay. You will get complete black screen here, okay. Here you have to type the program, and you know how to receive data from MQTT, right. So, let us do that. From space import space paho.mqtt.client as MQTT. So, this is the syntax which we have imported in the morning session also, right. In the first part, so we understood how to import a library. So, import space paho.mqtt.client as MQTT, and then we have to create a client object, isn't it, and then we have to create a client object. We have to create a client object. I am writing a comment for that. To create a client object, so client equal to MQTT.C client, client equal to MQTT.C client. So, after that we have to connect with broker, we have to connect with broker. So, client dot connect of broker dot hivemq.com comma 1883. So, this is how we need to connect with broker. So, broker is nothing but server here, and then we have to subscribe, on the topic. So, here client dot subscribe of madBlocks, client dot subscribe of madBlocks, and then we have to create a notification function. We have to create a notification function in order to print the message which is received on the topic name. So, def notification of client comma user data comma message, and then let me put tab space, okay. So, print msg dot payload, the same program which we written in the morning part, first part, and then we have to configure our notification function. The syntax is client dot on underscore message is equal to notification. So, we have to invoke the notification function whenever subscriber gets a message from the broker. So, that is nothing but on underscore message. So, client dot loop underscore forever, client dot loop underscore forever, okay. So, here after printing the message, so here we have to send this data. So, we have to send this data to blockchain, isn't it. So, as of now we have not created any program for the blockchain. So, let me do one thing, let me store the value of msg.payload in t, and let me print the value of t, okay. I can do this, right. Instead of printing msg.payload directly, let me store that value in some variable, and then I will print of t. So, which is nothing but the t value will be printed here, isn't it. So, this is the program of subscriber what we have discussed in the morning first part, right. So, hope let me copy this program into the Google Colab, okay, for reference. So, let me copy that. no need to do that, but for reference I am just copying it. Okay. Ubuntu, because you are having my Google Colab, right? Reference codes. Okay, I will create a special category and then I will write this Ubuntu reference codes. So, this is the first program. So, okay. So, you can take it from my Google Colab. Why not everything is copied? Something is went wrong. Only something is happened. Okay. Something is happened. Oh shit. What is happened? Okay, something got happened. Anyways, I'll check it back. Okay, so let me save the program. So this is important. So if you want to save the program, Control X, Control plus X. So you will have commands here. Okay, Control exit, Control X. Then it will ask yes or no. Yes or no, press Y and hit enter. Okay, then you will go back to this control sudo nano. Say if you are in the program, you have to press Control X. Okay, Control plus X, press Y and hit enter. Control plus X, press Y and hit enter. Okay, Control plus X. So you should understand how to exit. Control X, Y enter. Control plus X, Y enter. I have done it. Say Control X, and it will ask you to save modified buffer. You have to press Y. File name to write the same program, right? No need to enter anything here. Just hit enter. So you will go back to the shell. Sudo nano. Go back to the shell. Now you can execute the program here. Sudo space python 3 space mqtt sub.py. Okay. Now it is waiting here. So it is waiting for the data. So let me run my publisher program. Okay. Let me run my publisher program. So where is the publisher program? Here on my Google Colab, isn't it? So let me run this program. If I run this program onto the Ubuntu machine, it has to receive the data. So what happened? Oh, something is missed. everything is right. It is publishing the data, but this fellow is not receiving it. Why? What happened to this program? MQTT sub.py, so it has to receive client.connect, client.subscribe. We have created a client object, we have connected with broker, we have subscribed on a topic madBlocks. So let us write print broker connected, so that we will understand whether it is connected with broker or not. And then client.on_message, client.on_message equal to notification, notification, client comma user data comma message, print of t, send this data to blockchain. Okay, so control X Y enter. Let me clear the screen. Sudo python 3 mqtt sub.py. So broker is connected, but it is not receiving data. What happened to he? So here data published to blockchain, madBlocks str of t. So client connect publish. It is saying broker connected, but we are not able to receive data. So why? Have you got data? For me it is not receiving. Why? T equal to msg dot payload, print t, client dot on_message equal to notification, forever. Sudo python 3 mqtt sub.py. Broker is connected, but it is not receiving data. What is the problem? Have you all got any data there when you run the program? Client.subscribe, so we have to subscribe, and then we have to define the notification. Every process is correct. T equal to msg.payload, client.on_message equal to notification. So client.loop_forever. Loop_forever. What happened? Broker connected, print of t. Okay, let me do one thing. Let me stop this. Broker connected, but it is not receiving any data. So, are you getting the same problem here? Notification is a function of notification. Have you, did anyone got the data, or you are getting the same thing like me? On underscore message equal to notification client dot loop underscore forever print of t notification client user data message. broker.hivemq.com. Nothing is correct, but why it is not receiving data? Not pinging. It means that internet is not available, I guess. So you have to get the data, okay. You have to get the data on the Ubuntu machine, but for me it is not receiving here, so there is something missed. You have to get the data like this, okay. So morning in the first part we have got the data like this, right. BID colon 1 temperature sensor value is this. In the similar way, you have to see the same data on the Ubuntu machine also, okay. But for me it is not receiving up. There is some problem. It is not problem with the program, I guess, because program is correct. So have you got any data something like this on the machine, which is like BID colon temperature sensor value and the rainfall sensor value there. So you have to get the data something like that. So for me it is not receiving, I don't know why, but it has to receive. So after broker connected, it has to display the data. I don't know why it is not receiving here, but there is some issue on the here on my system. So it has to show the data here, okay. For me it is not showing up, so I'll try to debug this after a while, okay. So maybe afternoon at 2 o'clock we are having one more part, right. So that time I'll try to debug this, okay. There is some issue with, I guess, firewall. Let me disable the firewall, otherwise. So let me disable the firewall, maybe that is also a problem here. Control panel, open. So let me disable the firewall. Allow an app through Windows firewall. Let me yeah, for some people they are getting, I guess there is a problem with firewall, that is why it is not coming up for me. So let me check the firewall status. Okay. Yeah, that is the, I'm getting data here. I guess that is the problem of my firewall, I guess. Let me put a different topic, okay, so that let me put, I will put madBlocks 1 in order to check, okay. So let me write the same topic name here. It has to receive because the program is 100% correct. Okay, madBlocks 1 here. It is the problem with the firewall, I guess. Broker has to be connected. Okay, let me run the program. It has to send the data. This fellow has to receive it, but it is not happening the right way. Let me open it again, this time with run as administrator. So I am just checking the, it has to display the data, okay. I am just checking why it is not receiving the data. So anyways, it has to receive the data. So let me do it again. ls, so listing out all the files in the current directory. cd space bit-mesra, that has to do, and here let me type the command python 3 mqtt sub.py. Okay, password. Broker connected. It has to receive the data. For me, it is not receiving the data. Okay, anyways, let me debug it after a while. So let's don't waste the time. Okay. So for you it is working, right? So it has to work. There is some mistake in the network. So I'll try to debug it for the afternoon part. So let's jump into the real part, which we are here, right? So which is nothing but let us create a blockchain network. So after that we will able to send this data which is received from the MQTT protocol, and then we can complete it off. Okay. So now here what we'll do is, let us create a local blockchain network. Okay, let us create a local blockchain network on the machine and then we will try to add this data which is received from MQTT, okay, and then we will try to add to the block. So, let us create some few programs here in order to catch up with the blockchain network. Let us start creating scripts, okay. So, let us create some programs. Let us create some programs here. So, you can able to see my shell, okay. You can able to see my shell. So, let us start programming the blockchain. Sudo space nano space block.py. So, here what I have to do is I have to create two programs. One is called block.py. So, which here this block.py is nothing but a block class which holds all the details related to it. Something like, you will have details like transactions, you will have, if you look at the block, you will have a block header, right. So, you will have a timestamp when the block is added, or you will have the details like transaction, which is nothing but a piece of information. You will have details like hash code, the previous hash code and all, and also the hash itself, the hash of the block itself, and also you will have nonce, right. So, you will have all the details related to the block in the block.py, and also for every block you have to understand that your data has to be hashed, right. So, that all those kind of operations will be doing it in this class called block.py. So, I am creating a file sudo space nano space block.py. Okay, on the Ubuntu machine I am creating a file called block.py. Sudo space, why sudo I want to use here, because it is a local user. So, I need to take permission from super user. Sudo space nano space block.py. Okay, let me zoom it for you. Sudo space nano space block.py. Okay. So, after typing this, let me put enter. So, if I put enter, a empty file will be created. So, in this empty file, we have to write programming, okay, related to the blockchain. So, here this program is related to block, okay. It is not related to blockchain, it is related to block. So, here we have to create two different classes. One is block and the second one is chain, okay. So, which means that blocks are added added to the chain, right. So, the new blocks will be coming into place, and the new blocks will be added to the chain. So, here that is why we have to create two Python scripts, one which focus on block, second program which focus on chain. So, here let us start with block program. So, this is a block class, okay, this is a block class. So, let us import some libraries, because Python is popular because of its libraries and frameworks. So, here let me import some libraries. So, you have to understand which kind of libraries you have to import here. So, we have to import two libraries here first. So, let us start importing the libraries, okay. Let us start importing libraries. So, we have to import the libraries which is like from date time import date time. So, from date time library, date time is a built-in library which is used to understand when the block is appended to the chain or when the block is created there. Okay. So, from date time import date time. So, which means that from library date time import date time. So, date time is a method here which is a module. So, this is a built-in module in Python 3 or Python 2. This is a built-in module. So, we can easily import that, and also hashing is important, right. So, hashing is very, very important. So, we have to understand whether data is for blockchain is very popular because of transparency. So, we have to hash our data which is coming up to the block. So, that is why we have to import a library called hash library. So, which is also a built-in library in Python. So, we will be using a module called SHA-256 for doing hashing on the data which is confined to the block. So, we have to import these libraries. Let me tell you step by step, so that it will be easy for you to understand what is happening out there. So, importing libraries, we have to import the libraries first. So, we have to import two libraries here, and then what we have to do is we have to create a class. We have this, the main agenda of this program is to create a class. So, let us create a class. So, class space block. class space block colon. So block is nothing but name of the class. So class is a keyword in Python which is used to create classes in Python. So class space block colon. So every branch should have colon at the end, right? So here block class will have multiple number of statements, thereby colon comes into place. So we have created a block class and tab space, or you can use 2 spaces, whatever. Okay. Def. So if you are not happy with 2 spaces, you can give tab space also. Def space. So we have to create a constructor for the class. If you are good at object oriented programming, you can easily understand what is constructor and all, right? So we have to create some constructor. So whenever the class is called, this constructor will be activated, right? INIT. So double underscore. So def space double underscore INIT double underscore bracket open. So there should be a self as an argument, which is like a constructor object to access it, and transactions. So transactions are nothing but data which is coming up to the block, right? Transactions comma, and every block will be having its previous hash, right? So which is like address. So previous hash, previous underscore hash comma. So let's default, let us put the number at once, like nonce equal to 0, okay, which is like, the default value is 0, but we'll change it in the script, okay. So later, so as of now it is 0 by default. So what we did here, we have created a constructor by passing some arguments which are like, self comma transactions. So self is a built-in keyword, okay, so no need to bother about it. Transactions is nothing but piece of data which is coming to the block, and previous hash. So every block should have a previous hash. So in order to connect with chain, right? So that's how a blockchain is framed, right? And number at once equal to 0, which is nothing but that is used to use it for proof of work. So let us initially the value be 0 colon enter and give tab space and then tab space again. So let us store some values, okay. So self dot timestamp. So self dot timestamp equal to date time is a built-in module date time dot now. So you'll be getting the date and time, year, microseconds, everything will be stored in timestamp variable here. Okay. So whenever the block is created, whenever the block class is called, immediately, so it will be capturing the time by using date time library, and that date and time will be stored in a variable called timestamp here. So timestamp is nothing but variable. So that will be assigned with date and time whenever the block class is called. And also let us store the transactions, okay. Let us store the transactions. So transactions equal to the argument there, transactions, and then let us store self dot previous hash equal to the argument there, which is previous hash, and then self dot. So let us have the number at once, which is nonce equal to nonce, and let us have the current block hash code, right. So let us have the current hash, which is like self dot hash equal to. So here we have to generate some hash for this block, right. So let us define a function, okay. Let us call the function member function, its own member function here, self dot generate generate whatever. So generate underscore hash. So every block will have a hash code, right. So self dot hash is nothing but its own hash code, its own hash, and so here it is assigned with 0 default, but every time it will be changed, right. So number at once in the sense, so every time you will get one unique number, so that will be assigned to this, okay. So by default it says 0, but that will be passed when you jump into that, okay. And then previous hash, which is nothing but previous the previous block hash code will be assigned to previous underscore hash, and transactions here. So the transaction is nothing but piece of data which is coming to the block, and the date and time is now assigned to timestamp here. So this is the constructor here. So we have to define some member functions. So let us talk about the member functions, okay. So let me define some member functions here. So def space print underscore block. So this is one member function in order to print the block data. Okay. So let me put some space. Okay. So here let me print, let me define the print underscore block, which is nothing but which prints the block details there. So this is one member function which we have to create. Let us have a pass. Okay. So as of now, so we have to write something in print underscore block, and also we have to create one more member function here, which is generate underscore hash of self. So here also we have to write something here. As of now, let us put pass, and then we have to create one more function called def space print underscore. Let us use print underscore block itself. Okay. So let us use the same function. Okay, whatever. So here this is the block class. In the block class, what we did here, we have created a constructor, and we wanted to create two member functions here. One is print underscore block. So this print underscore block is all about printing the showing the block details. Okay, and this function is all about generating a hash code for the block. Okay, so this is to generate the hash code for the block. So let us do hashing first, and then we'll go for print underscore block. Okay. So let us do hashing. If you want to do hashing, we have imported a library called SHA-256, right? So to do that, what we have to do is we have to create a string first. So let us have the string like the block contents, whatever. Okay. Let us create a string. Okay, let us create a variable. We can create variables directly, right? So block contents equal to what is the first variable there? Timestamp, isn't it? So let us have self dot timestamp. So that is a variable which is written in the constructor, right? Self dot timestamp, that is a variable which is written in the constructor, but we have to append as we have to typecast it as a string. Okay, we have to typecast it as a string. Okay, and then block contents plus equal to, so plus equal to is a compound assignment operator. So we have to append the second variable there, second data, which is nothing but transactions there. So self dot transactions. Okay, and then what is the next data available there? Previous hash, right? So every data has to be appended into one string, thereby we can create one hash for the entire data. So let us append that by using, what is the next one, which is previous hash, right? So self dot previous underscore hash, but you have to convert into string. So you have to typecast with string. Okay, and then we have to add one more parameter, which is nonce block contents plus equal to str of self dot nonce, and also we have to append one more thing, which is nothing but its own hash, right? Okay, that is hash, anyways, that will be created. Okay, so these are the variables, right? So what we have to create? We have to create a hash for this string. So what is, in which string it is getting stored? So all the data is appended to block contents. Now we have to create a hash for this. So let us create a hash, say block underscore hash equal to, we have to use SHA-256, that is a built-in method which is available in Python library there. So SHA-256, so you will be having a function here, SHA-256. So here you have to pass encoded data of block content. So we have, everything is appended to a string called block contents, so which is nothing but block data, block contents dot encode. So we have to encode the data, dot encode. So we have to encrypt the data. So because at the other side you have to decrypt it, right? So we have to encode the data first, and then we have to return, and then we have to return its hash, right? Return block underscore hash dot x digest. We have to get the data in terms of hexadecimal values, right? So X digest. So, you will be getting the hash code generated for the block. So, here if any parameter is changed, hash will be changed, right. If any date, if any piece of information is changed, if a timestamp is changed, or if the transaction is changed, if the previous hash is changed, or if the nonce value is changed, so your hash will be changed automatically. So, every string will have its own unique hash value, right. So, hash will be changed. So, here we are returning the value of hash for the block. So, when this function is called. So, this function is being called from here, right. So, self dot hash equal to self dot generate underscore hash. So, immediately this function will be called. So, inside this function all the data will be binded as one string, and then hash values will be generated by using SHA 256 algorithm. So, the data will be encoded first and the value will be returned, and that return value will be stored in a variable called hash here. Okay. So, let us print this data. So, let us print this data here. Let us have a print statements here. So, before we go for lunch, so let us print the statements. Print timestamp colon comma self dot timestamp. Print double quotation open transactions colon double quotation close comma self dot transactions. So, this is the data which we wanted to print, okay, for us to understand what is happening out there, and the current hash. So, what is the current hash of the block? Okay. So, self dot generate hash, or it will be there in the hash, right, self dot hash or self dot generate underscore hash, whatever. Print the previous hash colon. So, what is the previous block hash? Okay, self dot previous underscore hash. Okay. So, thereby the member functions is created. So, we have created two member functions here. One is print underscore block, the second one is generate underscore hash. So, generate underscore hash will be where we will be creating a hash code for your block, and that will be appended to hash variable here in the constructor. So, when this block is called, then immediately the hash will be assigned to the block, all the parameters will be assigned to these variables, and these variables we are calling them in the print underscore block function in order to see what is happening there, and thereby this class is done. So, we are done with block class. So, there are two member functions here, and then we have the constructor there, and thereby we are done with this class. Okay. So, let me exit from this. You know how to exit, right? Control X, Y, enter. So, you will come out of this. So, we have sudo nano block.py. So, this block class will be called from blockchain. Okay. So, we have to create one more class. So, we will be doing it in the part 3. So, in the part 3 we will be creating a blockchain class. In that blockchain class we will be calling this block class for for appending the blocks to the chain, and also you will have a lot of metrics around the blockchain, right. So, we will discuss in the afternoon at 2:30. Okay. So, any doubts in this session, please let me know. So, I will check that MQTT, I will solve it before we get into the next class. Okay. So, I will solve it in the break. So, what is the problem of MQTT live on the Ubuntu machine? For me it is not working, I guess for some people it is working, right. My program is correct, I guess, but there is small configuration needed. So, let me check that. So, any doubts? Thank you for joining me in this part. I will meet you at 2:30. So, in this part we have created MQTT MQTT subscriber program on Ubuntu machine in order to receive the data, and then we have created a block class where we have taken two member functions here. One is print underscore block, and the second one is like generate underscore hash in order to generate the hash for the block. and we have taken one constructor also. So, constructors are very important. When the class is initiated, then immediately the constructor will get activated, right. So, it will be accessed. So, these are the things which we done in the part 2. So, in the part 3, so we finally create a blockchain on the local machine, and we will try to add all the blocks that comes in from MQTT program, and we can able to see the output there. Is that fine? If you have any queries, you can send me a WhatsApp message or you can send me an email. If you get any error in the program, you can put in the WhatsApp group, okay. So, my fellow members will be able to solve, okay. So, hope you are loving the hands-on sessions. We will meet you at 2:30. Thank you all. Have a nice day. Bye.